Yes, Neha, Simrah, am I audible to both of you?
Yes,
Yes,
ma'am. Good
ma'am.
evening, ma'am.
See, this question was given, and I think you people are having doubts in the first question. This is a graph that shows the distance versus time between two trains. Train A is there, train B is there. Now, both of them are moving simultaneously in the same direction, and the graph is given. So this is what kind of graph? This is a distance time graph, first of all. Second, they are moving simultaneously, means the time gap is not the different. At the same time, they are moving in the same direction. Now, when we are talking, the question is saying which is ahead of A, how much ahead of A is B when the motion starts. See, first of all, the check the units whenever you have the graph. This is given in kilometers. This is given in hours. So there's a difference. You cannot write your answer in meter per second. This is given in kilometer. This is given in hours. So whatever answer you will get, that will be kilometer per hour. Now look, the first one says this is at the origin. Okay, how much ahead of A is B when the motion starts? This is exactly at the origin. Look at this. This is A. So this is the graph of A. When the body starts, where is A? A is at 0, origin, right? A is at the origin. For the first one, A is at the origin. Means covering 0 kilometer. It has covered 0 kilometer. For the same time, at 0 second, time is 0 second. So at 0 second, A is covering 0 kilometers. For the same time, t is equal to 0 second. Look at B. There's a y-intercept for B. This is your B. B has already covered 100 kilometers. So this B is at 100 kilometer distance already when A has just started to move. So how much ahead of A is B when the motion starts? How much ahead of A is B means B is ahead of A by the distance of 100 kilometer. This much is how much? 100. So B is ahead of A by, this is 100 kilometer. So 100 kilometer means, C class, what is meant by 100 kilometer? You have the intercept present. Take the same common time for it. For the calculation, take the same common time for it. Okay, whenever you are calculating. Like the second part says speed. What did we discuss? The speed is given by which kinds of graphs? Yeah, Simra, your camera is off since few days. What is the speed of B? See, the graph has already given you markings. Q point has been marked, R point has been marked, P. Now, speed from distance time graph is given by the slope of the graph. We have studied that the slope of the graph, that is tan theta, gives you the speed, because distance divided by time will give you speed, and that can be calculated through the slope. Now, we have to pick a triangle for it. You can pick any triangle. If you look at this triangle, PQR, tan theta can be written as QR divided by PR. Why am I picking this triangle only? Why not this triangle or this triangle, any other triangle? Because for any other value, the A's value will be 0. We have to choose a point when both the bodies are moving and are covering some distance. Here at this 100, at least this in triangle PQR. This is from the triangle in triangle PQR. At least now what do we have? We have this perpendicular divided by the base. So what is your perpendicular? 150 minus 100, right? Your perpendicular will be 150 minus 100. So this is, or let me write it, 150 minus 100 divided by, what's the PR? 2 minus 0. That is 50 divided by 2. So answer of B this answer is 25, but what's the unit? Kilometer per hour. Neha, in your entire your second question was perfect, Neha. In your first one, you have written meter per second for all of it, not meter. See, in graphs,
Yes,
always
ma'am.
check the units. Yes, Neha.
Yes, ma'am. I'm gonna
Okay.
ask a doubt.
Yeah, you had the doubt also in this question. So that's why I'm
No, ma'am.
discussing.
In the second one only, can't we take, because we can already locate the time and the distance of B, because B is ending at 4 seconds and it's ending at 200 kilometers. Can we do 200 by 4?
What?
When we check the graph,
Mm-hmm.
B is ending at 4 seconds and it's ending at 200 kilometers.
B
So
is
can't we
ending
do
at 4.
200?
A is ending at 3.
So for speed of B, can't we do 200 by 4 distance by time?
Distance divided by time. So total distance. So B, for A, what will you choose the distance as?
That's where I had the doubt then.
No, that's why you cannot use, because A is just given randomly. See, for A, they have not given a value. Otherwise, that could have been that. Because ultimately, you have to apply the formula also, so that is fine. See, in the graphs, it's better you avoid the formula. Go by the two things: distance by time. If it's the graph is distance versus time, so distance by time is B, which is given by the slope means tan theta. Tan theta's formula is perpendicular by base. So just have it in your mind, you have to take y-axis component by the x-axis. Now if I choose some other triangle like this one or this one or any other, for those triangles I'll not have the specific value. See, if I choose the smaller one, it's not giving value. This is a triangle. That's why this question has marked, right? It has already marked the Q point, R point, P point. So you consider this triangle only. Now, when and where will A catch B? So see, where in the two lines of A and B, where are they both intersecting each other? And they're not intersecting.
At 150.
At what point?
150 and 2 seconds, 150 kilometers.
Q point, no.
Oh,
This,
we just have to
right?
mention Q. We don't have to write the
Yes.
value.
This is the
Okay.
point that is Q, right? Here they are intersecting. Now, it is saying when it will catch means it will catch it at where it will catch at Q point, right? And what is this Q point? Now you see 150, it is saying 150, distance of 150 kilometer from the origin. Don't take these distances, subtracting 100, subtracting 50. No, you have a reference origin. Now, if I answer like in the first part also, I have answered B is ahead of A by 100 kilometer. See, it's the safest to take from origin. If I say 100 kilometers from the origin, that's correct, this much distance. If I want to say at this point, now I know that they both are intersecting at this point. By looking at the graph, you can see they both are intersecting at this Q point. Now you have to describe it. So see, distance, if you look here through the graph, this is 150. So when and where will be 150. If I write 150 kilometer from origin, 150 kilometer from the origin, so at least this exact value can be traced from the origin. Mark 150 kilometer. Now if I take a difference 150 50 minus 100 and all, that won't give you precise value when you already have the values to be taken. Like this speed calculation, it wasn't so easy. You cannot just look at the value and answer. So you had to take the triangle. But if 150 is given, directly take 150 from the. And when will they catch? So at Q point, what is the time? 2 hours from the origin, right? 2 hours from their beginning. So when and where A will catch B means when they both will intersect each other. They are moving simultaneously and they are meeting at a point. Remember, we did a question also. Two balls were thrown simultaneously, one from up, one from down, and both the balls were asked to meet. So something like this. So 2 hours from the starting. Now, when you mention 2 hours, you have to mention this from the start. See, when you have the graph and something is with reference to origin, no, try to answer in terms of that, because you'll always be at the safe side. From zero to this, from origin to this. So it will be very easy to trace. Okay, from zero, it means she actually knows. Then it is saying what are the differences between the speeds. See, when you are calculating the speed of B, you have already calculated in this part. 25, yeah, here. B is already there, 25. Now speed of A is there. Speed of A also has to be calculated. So for the speed of A, now only speed of A is there. Now I can take this bigger triangle. Look, this tan theta. If I take bigger triangle, this hypotenuse is of A. So I'll get the answer of A. When I had the point B and I took this triangle, that time, this was the theta. Look, hypotenuse was of B. So speed of B was calculated here, 25 kilometer. But right now this theta, the hypotenuse is of A. So for the fourth part I think, Neha, you had a complete doubt in the fourth part, right? So see,
Yes, ma'am.
yeah. So fourth part, you have to take this point. Now take it. This is the hypotenuse, perpendicular, sorry, not the hypotenuse. This is the perpendicular, which is 150 by your base is 2. So you get 75 kilometer per second. And what's the difference? Delta V will be V2 minus V1. That is 75 minus 25, which is equal to 50. So your final value is 50 kilometer per hour. Not seconds. Seconds we'll not use in this question. So let me just repeat it quickly. What did we discuss here in this question? It said that distance versus time graph was given. This is a very important question. It will cover a lot of aspects in this. Distance versus time graph was given to us. Two quantities were given. You have to read the graph. How much ahead of A is B when the motion starts? So when the motion starts, put your pen at the origin when the time is 0 second. Then look, what's the distance covered by the B at that time? 100 kilometer, answer 100 kilometer. Speed of B, okay, B is this, so you have to construct a triangle. If you are able to construct this triangle, a triangle like this, and you can get the values, then it's fine. But if you know for B like this, you will get the same value. But it's better, and even if you take the smaller triangle, then also it's correct, like this. Because ultimately you have to tell the theta. Theta will be equal for this smaller triangle. Theta will be the same for this bigger triangle. So tan theta is the only solution for the speed. Third part, when and where will A catch B means at what point are they intersecting? This is what is meant by the question through this statement. They are intersecting at Q point, so it is asking you the coordinates. Express Q points. Q point. How will you write Q point as your answer? So Q point means 150 kilometer from the start, 2 hours from the start. That's it. What is the difference between the speeds of A and B? B we have calculated like this. For A, you just have to find out this angle, theta. So what you can do for A, you can calculate it like this. This big triangle also you can take, or this smaller triangle also you can take. Now it depends on what values do you have from the question. This we don't know. Whether this is 3.5, it can be anything. We don't know, is it lying exactly in the middle point or not. Let's take the smaller one. For the smaller one also, this triangle is there, which will give you theta. This bigger triangle will also give you theta. Triangles, the sides can increase, angles cannot increase more than 360 degree, but the sides can have any values. Angle will always remain the same. If it is 30 degree for this smaller triangle, it will be 30 degree for this bigger triangle also. So if you know the value, use it. But right now I didn't know this before this part. So I just took the smaller one 150 divided by 275. Here 50 divided by 225. So when I subtracted, it was 50 kilometer per hour. Is it clear to both of you, this question properly?
Yes, ma'am. Yes, ma'am.
Okay. Please write down this one. Second one, both of you were able to do. Second one, you people don't have doubt. Second one was easy also. But this was a very good question and this has a lot of concepts. So please write it. Just text me done once written. Okay, class. So we were discussing the velocity versus time graph. So, Simra, your exam is on, I forgot, 19th,
14th, ma'am.
14th. Okay, Wednesday. All right. So, how's your preparation?
It's going fine, ma'am.
If you have any doubts, let me know. Tomorrow is the last day we have before your test, and both the chapters are covered. Luckily, in your school, only these chapters are coming, which we have done it also. See, today we'll have a practice session, so at least it will help you. Otherwise, also, I asked both of you that in today's class, we'll at least discuss this whole chapter because this is a very important and a lengthy chapter. Some good questions, some important questions we'll discuss. So, Simra, you practice them also. Okay, and take the
Yes, ma'am.
revision tests from us. Attempt the revision test. If you're able to score well, did you receive the revision test?
Oh, which one, ma'am? The result for the last one.
No, no, not the weekly test. That you people have done excellent, both of you know. Not the revision test, any revision test of the first chapter.
No,
You have
no,
not
ma'am.
received it.
It's
I'll
all
share it
right.
with you today.
Mm.
Attempt it like a proper test of dimensional analysis first. I'll share it today. If you are able to
Yes,
solve
ma'am.
that paper, at least 70 to 80% of that in your school, you will not have any trouble for dimension from the dimensional analysis part at least. Okay, so attempt it
Mm.
like as if you're giving it for the test, a mock test. Okay, we'll
Yes, ma'am.
share it with you today. Let me just tell you. Let me
Mm.
just inform. So, Neha will have the exams in the month of June. Yeah,
No, ma'am. It's May 26th,
it is
physics.
26th.
Yeah,
Okay, and what's the
I just
syllabus,
got the
Neha, for you?
first three chapters,
First three
40
chapters.
mark paper.
Okay, 26th. So we have one class today, then four classes are there. Okay, Neha. Projectile, I think your third chapter will also be done by that time. Okay. Let let us complete this chapter first. Yeah. See, class. Till here you have written these points also, no?
Yes, ma'am.
Okay. So see, for uniform motion, if you get the graph plotting, acceleration is 0. Okay. Slope is 0. Because for V versus time graph, the slope will give you the acceleration and the area under the graph will give you what?
The speed, right?
Displacement.
Displacement. Displacement. Hmm.
Displacement, right? So for velocity, it will give you displacement. For speed, it will give you distance if it is speed versus time, right? So A is 0 means slope is 0. Now, if velocity is constant in this uniform motion means, remember, we discussed that in uniform motion, acceleration doesn't change. So slope will be constant. For example, acceleration, you have V versus T graph. You are having a positive velocity. Okay, the value of velocity is positive. And acceleration is 0. Slope is 0 means there is no acceleration. So when we say there is no acceleration, means is the velocity changing? No or yes. If acceleration is 0, is the velocity changing or not?
No, because acceleration is rate of change.
Yes.
Velocity.
Acceleration is change in velocity. No change in velocity, no acceleration. So it means velocity is not changing. Means your velocity, suppose this is a value of velocity, it will remain like this. The constant graph we discussed, see, slope is also 0. Calculate angle. Will you be able to calculate, make any triangle? You will not be able to make any triangle. Slope is 0. Slope 0, acceleration 0, but velocity positive. Look, everything is being explained in the graph. Same thing if velocity is negative. So just draw it in the fourth quadrant where velocity is negative, but your time is positive. Right, this one is, just draw it as a straight line. This is actually a straight line. Okay, one case is when your acceleration is positive this time, means it is non-zero. Acceleration has some value. Time and velocity both are 0. Means t is 0, v is 0. Acceleration is positive means slope is positive. Slope positive means just think it in the mathematical terms. They will give you the variables. Questions work is to give you the variables and confuse you. You don't consider the variables and get confused. You consider the mathematical part in the graphs. Don't read the graphs like you are reading a story that, okay, this is moving like this. No. Triangles, slopes, area, which graph, take it like that. Now, acceleration positive is for the question. For us, what we will deduce from it? We will say acceleration is the slope of the graph. Slope is positive for us. Slope positive means tan theta is positive. Tan theta is positive means theta is positive. If theta is positive, then only tan theta will be positive. When can we have theta positive? Angle is acute, 0 to 90 degree. So we have acute angle throughout. This is positive. Acceleration negative. Velocity is positive. Time is 0. So I cannot plot it somewhere here. No. time is 0. So this part will not be used. Velocity is positive, acceleration is negative. Means, see, if I have some value, let's say from here, so this will be somewhat like this. Graph is starting from the value of some positive v. This part is the positive v. But I could not draw it like this. If I had drawn it like this, positive angle, positive things will come. Acceleration is negative. Now see, from the horizontal, if you see, this is obtuse angle, which is making it negative. So this is how it will be. Now, what exactly at it, what is the exact point, where is it ending? That will be described by the question. Now, t is 0, v is negative, acceleration is positive. Look at this graph. Velocity negative, so here. Time was 0, so we cannot start from here. Velocity was negative means initially there was some velocity, so we started from here, negative, fourth quadrant. Acceleration positive means you have to have a constant graph, constant slope. Theta has to be acute. So this is the only way. If one more case was there, is it there? No. If case fourth was there, V negative, A negative, then the graph would have been C. V negative means here T is 0. T 0, V is negative, acceleration is also negative. So if I go like this, it will be same. So like this, obtuse, if it was given, in case. Okay, so just read it systematically and whatever you've studied, apply the basics. Main part is this class, this one. That when you divide two quantities, that is given by the slope of the graph. This is very important what you've written. And when you multiply two quantities and you're getting the third one, then you take the area under the graph. Properly take half into base into height. Trapezius is formed half into sum of parallel sides into height. A rectangle has been formed length into breadth. Like this, properly take the area, the geometrical area which you've studied. If two quantities are getting multiplied and the third quantity is given by the multiplication of these two, like distance, velocity into time, right? Velocity multiplied to time. Or if we have two things getting divided, then take that y-axis component divided by the x-axis component. Basically, we do this only, y-axis part divided by x-axis part. That we write, what are we doing? Y by x means perpendicular by base, which is tan theta, which is the slope. That's why these all things are the same, slope, tan theta and all. This is very crucial for the graph because class, your graphical part is not limited to this chapter. Whatever graphs basic, why did I do this in so detail? You just have one or two kinds of graphs from this chapter that can come. We started with a linear equation graph, kinds of constant slopes, kinds of decreasing graph, and so we did it in so detail because that is not for just your class 11. You will come in class 12, you have your class 12's portion also to deal. So this is cumulatively full graphical portion that is required by you in class 11th and 12th. So remember this thing. Always remember this example like this. You will have work done and there you have lots of graph in this class only. Work, energy and power is a chapter. From there you have lots of graphs. Okay. So please start writing from here. This graph also you both have plotted?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, class, see, this is a graph. You have to now read the graph. This is saying this is a graph between what? Velocity versus time. So when velocity versus
Velocity
time
time
graph,
graph.
yeah, Simra, yeah, okay, you were saying this only. Okay. See, when you have this 0 to this first point, okay, this is, let's say this is A, this is B. So O to A, slope is a constant slope. So the slope will give you acceleration. And for displacement, you need this area. Similarly, this part, then let's say this is C point, let's say this is D, this is E point, just for the references. Displacement covered in 10 seconds. 10 seconds matlab pura yahan tak, right? Total is 10 seconds. So it means we have to it is saying displacement, so you have to consider this negative part also. In distance, you cannot consider negative part. You never subtract in distance. So for distance, forget this. But displacement, all entire area covered till here. So see, you can solve it like this: half into base into height plus length into breadth plus half into base into height for this part, or simply as a trapezius you can solve half into sum of parallel sides into height. Like, let me write it on it. For the first part, it is, if we take, see, the displacement will be the entire displacement will in 10 seconds will be trapezius, area of the trapezius plus the area of the triangle. So area of trapezius half into sum of parallel sides. Let's check it. This is 4 minus 2, right? This much. It's 2 seconds. Look, 2. So sum of parallel side 1 is 2 plus. What's the other parallel side? Till here it is 6. Okay, till here it is 6 seconds. So this will be 2 plus 6. It is 2 plus 6. Half into sum of parallel side into height. So height is missing. Height is this, which is given as 10 meter per second. So into 10 plus the area of the triangle. Triangle will be half into base. Base is this. So 10 minus 6. This part is 4 into height. Now look, automatically we are getting minus 10 here. Height is minus 10. So take it as minus 10 because this is displacement. Okay, into minus 10. So this will be now, what is this? 2 plus 6, 8. 80 by 2 plus, what is this? 2 minus 20. Okay. So this, let me write it minus 40 by 2 lines. So this is 40 minus, this part is 20, correct? 40 minus 20. So that is 20 meter. This is the displacement. Now look, what will be the distance? Distance will be 40 meters. In distance, we are not going to consider this negative part. For distance questions, if distance comes, then this negative part of the area becomes useless for you. Because this area is half into base into height. What's the area? It finally came minus 20 meters square. The area is minus 20 meters square. Minus is for displacement. That shows that it is considering the direction. When you have negative, it is indicating that this is a direction, and distance is free of these directions. So just consider the positive parts for it. So this will be the trapezius. That is this part. So for the distance, second part, you will have, simply it will be 40 meter, sorry, not meter, square meter. Third part was also there, acceleration versus time graph. Now look, you have to read acceleration when it's the graph. Look, from O to A, what is happening? Slope is constant, angle is constant. In this triangle, if I take if I mark a cut here, if I mark a cut here, angle will be the same for this entire triangle here, whatever it is subtending. So you have to read the graph through slopes. Area work is done. Distance displacement is calculated. Now your area part is done. Come to the border because you are seeing the slope now for acceleration. So O to A, slope is constant, means acceleration is constant. Slope is constant means acceleration is constant. Now we are plotting acceleration versus time graph. So constant slope means constant acceleration value will be, see, look, for the initial time, this is, okay, one thing, acceleration's value we need to calculate first, because for marking like this was 10 meter per second. So, this is 10 meter per second, time is 2. So this highest value is 5 meter per second. 10 by 2 is 5. So for this, first of all, you calculate the acceleration only. Acceleration from the slope, you can calculate V by T. That was 10 meter per second divided by 2 seconds. That give you minus 5 meter per second square. Similarly, for the downward triangle, you will calculate that will come out to be minus 5 meter per second square. So you know the highest value now. Now we are plotting the graph. So graph is constant initially, means if it is 5 meter per second square, at every point till 2 seconds, it is 5 meter per second square only. But it is constant, so it's a straight line, right? At every value we are getting. So graph was this for Vt, acceleration is coming like this, it is constant. Now after 2 to 4 seconds, what is happening? Velocity is constant, no accelerations, means there is no slope. No slope means this is not a constant slope, there is no slope. Constant is this is no slope, velocity is not changing. See, you can understand it in two ways. One way is that velocity's value is initially also 10 meter per second, finally also 10 meter per second. So there is no acceleration. Here it was changing from 0 to 10, it increased. Here it is constant. Or second way is that you can see, one is that the graph from second one is through the graph. A constant slope means theta is 0. Slope is also 0. Right? So that way also, if you see, so it means acceleration is 0 in this interval. So till 2 seconds acceleration is existing, then 2 to 4 seconds, this is 0. Just trace it. Then 4 to 6, what is happening between 4 to 6? Okay, velocity is decreasing. What do we call this acceleration as?
Deceleration.
Deacceleration. Very good. Deacceleration or retardation. Both the terms are correct. Velocity is decreasing and coming back to 0. So what kind of slope we'll get? It is still a constant slope only, but with a negative acceleration, right? Velocity is decreasing. You are getting retardation value. So for this part, see, you will have negative, yeah, 4 to 6 seconds is there. From 4 to 6 seconds. Here, like, look at O to A part. What was there? The constant slope was there. Here also you will get a constant slope only. What will be the value of your velocity here? What is the value of your speed here? Again, it will be 10 divided by 2. That will give you. But keep it in your mind that this is deacceleration. Okay. So this will be, see, we are again getting a value which is 5 meter and we have this value. Now look, from 6 to 8 seconds, what is happening? Okay, now we are coming to the lower quadrant, that is negative part is coming because this is already negative. So see, here also same thing is there, constant slope, but the quadrant is different. Look, this is extension of this only. So this will be 6 to 8 will be, see, it will be like this, but here. Now we are at 8. Last is left, 8 to 10 seconds. 8 to 10 seconds mein kya ho raha hai? From minus 10, the velocity is increasing to 0. You are getting a constant slope, right? So this, but it's there, it's still giving you a negative value. Slope is constant. So acceleration will also be constant like this till here. This is the final value at 10. Got it? Negative, draw
Yes.
in the negative. Simrah, you want to ask something? Oh, please write this question. Okay, question you all have written. Write that. Okay, class, coming to vectors now. So basics of vectors I'm starting. Much time is not left. If it's possible, tomorrow I'll discuss some good questions from your first chapter. Otherwise, I'll give it in the form of assignment. I basically want to see how much you have actually understood from the first chapter. So tomorrow I'll discuss that part, because let us start the basics of vectors, at least now, because much time is not left today. So when we talk about the physical quantities, they are grouped into vectors or scalars. Now keep in your mind, chapter 3 has started and vectors is very important. Magnitude plus direction plus means vector laws. This means that vector is that quantity which has a magnitude, it will have a direction, and it will obey the vector laws, like your velocity, forces, accelerations. Scalar quantities mean they only have magnitude, they don't have any headache of direction, and using algebra they can be solved. Speed, mass, distance, all these are scalar quantities. Now coming back to your vectors, because this is a very random definition for you to understand at this level. Understand what is the meaning of magnitude and having a direction and obeying the vector laws. See, if I write the velocity as, velocity is minus 3 meter per second. Look, what is V? V is the velocity, which is the physical quantity. Equal to is the equity sign. Both of the sides are equal. Minus sign. This is telling you the direction. That whatever sign convention you have chosen as negative, it is in this direction. Like I have chosen downwards is negative, my velocity is coming negative, means velocity is in the downwards direction. That we discussed in the second chapter. There is one more question from the second chapter, which okay, let's just start with this. Tomorrow I'll discuss that question. That is a very important question. Please remind me just in case if I forget tomorrow. Okay, there's a very good question that often comes in your school exams. Now see, look at this 3. 3 is just the number. If I just take the value 3, so this is called as the magnitude. And this meter per second part, this is the unit. So this is how our vector is written. And when we say it has a magnitude as well as a direction, it means this. Or look at this example, F is equal to 2 Newton due east without any minus plus. F is what? This is your physical quantity. Right? 2 is what? 2, it is the magnitude. This is what is meant by the magnitude. Just the number without any signs. Numeric value, magnitude. We say the magnitude is more. Magnitude is very high. It means value, number is very high. 100 or 3, magnitude, greater magnitude will be 100. If I say minus 3 is bigger or is minus 1 bigger, in terms of magnitude, your 3 will be bigger. But actually with the signs, from the number line, minus 1 is greater. But when we talk about the magnitude, your 3 will become greater. Magnitude means just the value, numeric value, that's it. Again, now Newton, this Newton is the unit, and due east, this is the direction. So a quantity which has a magnitude, which has a direction. Till here it's not completed. You have vector laws also to be obeyed. 3 vector laws are there at your level and at any level also. You will be able to deal with them. One is the parallelogram law of vector addition. I'll not start with this. We'll do this later. Then you have triangle law of vector addition, and you have a polygon law of vector addition. Parallelogram law will be the most helpful, and your answers will be sorted through this. Triangle law is also, but you have all these in your syllabus, so you have to study. So these are the laws. So a quantity that has a magnitude, a direction, and obeys these laws, that is called as a vector quantity. Like your forces, acceleration, velocities, quantities which just have the magnitude and that's it. They don't need this direction. They don't need to obey the vector laws. For solving the distance, remember we used to add all the distances together. There was no headache in distance, just consider all the positive thing in the graph also. But as soon as displacement come, you have to consider what's the initial point, what's the final point. You just have to take the separation between them, because it is direction dependent. In vectors, anything can happen because of these laws. No, these laws have their specific formula. So if I say, let's say a simple number, 5 plus 1, in mathematics, in algebra, 5 plus 1 is 6. So this is 6 only in scalar quantities, because you are using your algebra. Because in your vectors, anything can be given. Angles will be given. Angles will vary your answer. When angles get multiplied, these things get squared up. So you get a new quantity. 5 plus 1 can be 0 also. It can be -1 also, it can be 3 also, and it can be 6 also. And 5 plus 1 getting the answer 6 is a very rare thing in vectors. In algebra, we just have 5 plus 1 is 6, you don't have to think. In vectors, anything can happen. Because we are not adding it only, there is a proper formula. And when you put this 5 and 1 in that formula, final answer can be anything. But this parallelogram law part, that we'll do later. First, there are various things that you need to understand. Two parts are there. But before that, one more thing here I missed. In some books, you will find the vector quantity is represented with a bold symbol like this. That's it, without any arrows, like this. For example, or the quantity can have an arrow on the top of it. If the arrow is present, it means it's a vector. Or it will simply be given in bold like this. This means it's a vector. Okay. Then you have the unit vectors and the magnitude of the vectors. See, when we are calculating the vector, this is what can happen here. And see, this is general notation or representation of vectors. So in some books you can find it like this, in some books you can find it other. Now in vectors, we'll be dealing with, now specifically talking about vectors. You have two forms of vectors. One is the Cartesian form, and one is the polar form. Now, when two vectors are given in a manner, when I say vector, don't think of something else. Just if you are getting confused, even a slight, just think it like two forces are given like this. Two velocities. I'm saying two velocities are given like this. So with the term vector, don't think it's a different quantity. You know vectors. Now you're just knowing how to solve them in any manner. Cartesian form means you are solving in terms of the graph through axis, coordinates, x-axis, y-axis, z-axis. We discussed in displacement question, the first question we did. Remember I cap, j cap, k cap, I told you. Remember 2a semicircle, I cap, forward,
Yes,
yeah, 2a j cap plus then 3a j cap, like this, that question was there. So that part, when you have the graphical part, coordinates are given, that is solved through Cartesian system. Polar means if I say two forces are there, F1 and F2, and they are making an angle of 30 degree. Basically, in polar form, you have angle. That is your polar form, where you need all these laws, which we studied. For Cartesian, there is a separate quantity here, separate method to solve all these. Dot product will come, cross product will come. So write it till here first. Is it clear till here, whatever I said?
yes, ma'am. Yes, ma'am.
Please write it.
What's the second word after general?
Second mode of representation, this.
No, ma'am, after general, there's a word written. What is that word? In the
Notation.
title.
Notation.
Okay, thank you.
Okay, notation means representation. Yes, class done, Neha and Simra.
Yes, ma'am, done.
Yes,
Tomorrow,
ma'am.
let us continue now. Much time is not left. We'll properly start with the Cartesian form only. But before that, we have to practice some questions from the second chapter, motion in a straight line. Okay. Just remind me once, there's one important question, alpha, beta, a question on alpha and beta that often comes in the school exam. So we'll just revise it. Okay, class then?
Ma'am,
Yeah, Neha.
ma'am, that example which was written on the board, 5 plus 1 is equal to 0 slash
Yeah,
negative
yeah.
1, that's vector addition, right?
Yeah, that's vector addition. This is not scalar.
Okay.
Scalar is your algebra
Okay.
only. This is vector. And how will you get this? This you will understand when you have the parallelogram law. Because see, if I say let's say this force is 5 Newton, this force is 1 Newton. When I added scalarly, means using algebra, I'll get 6, 5 plus 1. But because of this angle 30-degree, we can get any of these values. So that's why this I was saying this is due to the vectors. Okay.
Okay, ma'am.
All right then. Thank you. Let's meet tomorrow then. Okay. Bye bye.